In the previous example, clinical trials could only take on one of two possible outcomes. They could either succeed or they could fail. However, in reality, clinical trials can often have much more complex outcomes. And so when we're building these decision trees, oftentimes it makes sense to include these complexities. So in this example, in our phase 2 clinical trial, instead of having two possible outcomes, now there are three possible outcomes. In particular, there's an upside scenario where our new therapy shows a very strong positive therapeutic effect. There's an intermediate scenario where our therapy has a mild or weak effect. And finally, there's a downside scenario where our therapy shows no effect relative to the standard of care. And so in this upside scenario, it moves on to phase 3 clinical trials, which again are going to cost $50 million, have a 70% probability of success, and last for 3 years. If these phase 3 clinical trials are successful, our therapy is going to move to commercialization. And in particular, we expect, because this therapy has a strong effect, it's going to capture a very large market share. On the other hand, in the intermediate scenario, where our therapy only has a mild effect, in this case, again, it moves on to phase 3 clinical trials. And if we proceed with the phase 3 clinical trials, they'll cost $50 million, have a 70% chance of success, and last for 3 years. In this case, because our therapy isn't as effective as in the upside scenario, we expect that it's only going to capture a $50 million market share. And so that will be its commercialization value upon launch. And so again, the question is whether or not this company should go ahead with this $5 million investment in the phase 2 clinical trial. And so to answer this question, we're going to calculate the expected cash flows at the leaves of our tree and discount them backwards towards our first node. And while we're discounting, we're going to aggregate the cash flows along the way. And so let's start by calculating the expected cash flows in year 5 for the upside scenario. In this case, the expected cash flow is going to be equal to 0.7 times 350 times 350 plus, it's going to have a 30% chance of failure, so 0.3 times 0. And so that's going to be the expected cash flow in year 5, and we're going to have to discount that back to year 2 at a discount rate of 20% per year. So we divide by 1.2 to the 3. And when we evaluate that expression, we see that the expected NPV of proceeding with the phase 3 clinical trial in this scenario is going to be equal to $91.8 million. On the other hand, the expected cash flow in year 5 in this intermediate scenario where our therapy showed only a mild or weak effect after phase 2 is going to be equal to 0.7 times 50 plus 0.3 times 0. And again, we're going to have to discount this expected cash flow back to year 2. And so we divide by 1.2 to the 3. Now, when we evaluate this expression, we see that the expected or risk-adjusted NPV of choosing to go ahead with this phase 3 clinical trial, even though this therapy only showed a mild effect, is equal to minus $29.7 million. And so we see that this is actually a negative NPV proposition. So instead of going ahead with the phase 3 clinical trial here, the better decision is to abandon the project and just not go ahead with the phase 3 clinical trial. So we should abandon the project, in which case, instead of having a negative NPV, our NPV of this decision would be 0. And so finally, to calculate the expected value of our decision to proceed with the phase 2 clinical trial, we just continue this process iteratively. And so now we're going to calculate the expected cash flows in year 2, and we're going to discount them back to year 0. So the expected cash flows in year 2 are going to be equal to 0.2 times 91.8 plus 0.4 times 0, because we decided to abandon the project in this scenario, plus 0.4 times 0. And again, we're going to have to discount this expected cash flow back to year 0. And so we divide by 1.2 squared. And when we evaluate this expression, we see that the expected NPV of going ahead with the phase 2 clinical trial is equal to plus $7.8 million. And so this project has a positive expected NPV, and so we would recommend that this company proceed with the phase 2 clinical trial. On the other hand, let's imagine that the company naively went ahead with phase 3 clinical trial in this intermediate scenario, even though the therapy only showed a very weak effect after phase 2. In this case, what would be the expected NPV of this project? Well, now it would be 0.2 times 91.8 plus 0.4. But now instead of abandoning the project, we would incur a negative NPV of minus $29.7 million. So this would be times minus 29.7 plus 0.4 times 0. And again, we would have to discount this expected cash flow back to year 0. So we divide by 1.2 squared. And we find that the expected NPV of going ahead with the phase 2 clinical trial in this scenario, where we didn't have this flexibility to abandon the project after phase 2, would be equal to minus $0.5 million. And so we see that in this example, the option to abandon the project after phase 2, especially in this case where our therapy only showed a slight or weak effect, is worth $8.3 million. And in particular, this flexibility, this managerial flexibility, actually allowed this project, it actually converted this project from being a negative NPV project to a positive NPV project.